Today for your off-campus day, we're going to talk about the relationships between different measurements in chemistry. In particular, we're going to talk about how mass, volume, and particles are all related back to the mole. In order to do this, you need your note set, you need the Y diagram that I gave you guys in class, and your assignment for after that is going to be this mole and mass assignment. Alright, you also need a calculator. So let's get started. This conversion diagram right here shows you guys the relationship between mass, volume, atoms, and the mole. Now, we haven't talked about volume yet. That's okay. We're going to be doing that. We have talked about atoms and molecules, so that's these two paths down here. And then we are also going to be talking about mass, which we did talk about already with molar mass. So this little conversion diagram is going to be helpful. So for the first example on here, it says how many atoms are in 2.45 mole of copper. You're going to do this the same way we've done any other conversion. You start with your known, which is 2.45 mole of copper, and you're going to convert it into atoms of copper. How we use the diagram is by simply starting with our known. Our known happens to be moles, and we're going to follow the arrow that takes us to atoms or molecules. That's this arrow right here. On that arrow, you'll see that you have Avogadro's number of atoms over 1 mole. I know it's hard to see on the smaller version, but that's why I gave you guys the larger version. So what you're going to do is take that conversion and just write it in here. You can see why it works, because after I write it in there, I will have 6.02 times 10 to the 23rd atoms over 1 mole of copper. Mole will cancel out on both of those, and I'll be left with whatever 2.45 times 6.02 times 10 to the 23rd is. So I'm going to multiply that out on my calculator. Boom, got my answer. I'm just going to now check my sig figs. My starting amount is what I always go back to. So 2.45 has 3 sig figs. So I make sure that my answer also has 3 sig figs. So this is going to be 1.47 times 10 to the 24th atoms. That's a one-step conversion, just going right from moles into atoms. If we take a look at the next problem on there, the next problem says, how many mole do you have if you have 2.35 times 10 to the 24th molecules of water? So I start with my known, 2.35 times 10 to the 24th molecules of water, and I am going to convert that to get it into mole. Now when I look at my diagram, I'm going from molecules up to moles. That means I choose the conversion that's on that line. That happens to be 1 mole over Avogadro's number. So I'm going to write that right in here. 1 mole over Avogadro's number of molecules. And molecules will cancel out. Now, the key to these is to remember that on the bottom here you have 2 things. You're going to divide because it's on the bottom this time. So I'm going to type everything in, 2.35 times 10 to the 24th. When I divide, I have to put Avogadro's number in parentheses. Divided by parentheses. 6.02 times 10 to the 23rd. Close my parentheses. Now I'm going to get my answer. Now I check that for sig figs. I had 3 in my starting problem, so I'm going to go to that third sig fig, 3.90. mole. All right. And that's how you do moles to molecules, moles to atoms, or the opposite of that, molecules to moles, atoms to moles. All right. So then the next thing that we do here is we include molar mass in our calculations. Molar mass is a little trickier because you actually have to find the molar mass before you use it in the conversion. All right. So you're going to have to find those before you use them. But you guys were really good at that on the quiz, so I don't think that should be a problem. Okay, so I'm going to go to the first problem here. If I need 0.347 mole of magnesium hydroxide, how many grams do I need to mass out? See, so this is a real-world situation here because if I were setting up a lab for my students, I don't have a machine that's going to mass out or find the volume of moles. But my lab calls for a certain number of moles. The only way for me to figure out how many that really is to do it by mass. So I need to know if this is how many mole I need for a lab, how many grams is that going to be, because that's what I really have to calculate out here. All right, so the first thing that I need to do then is cancel out mole of magnesium hydroxide. Well, then that has to be on the bottom. All right, has to be on the bottom of that. Okay. Well, that's no big deal. I go to my chart and I'm like, well, on my chart I have to go from moles to grams. So this time I'm starting at moles and I'm going to follow the arrow that takes me to mass. And I do this conversion. That conversion says I'm going to do the molar mass over 1 mole. Well, great, because I already thought I had to cancel out mole here on the bottom. Now I know I have to put the molar mass up here. All right, well, I need the molar mass of magnesium hydroxide then. And like I told you guys before, you had to show me your work for a while. Now on the molar masses, you don't have to show me your work. I'm just going to add this up. I'm going to use my periodic table. Magnesium hydroxide, magnesium is 24.3, plus I have 2 oxygens in there, so 2 times 16, plus 2 hydrogens, so 2 times 1. So the molar mass of magnesium hydroxide is 58.3. And that goes in there. When I look at that calculation, I can see since it's on the top, I multiply by the top, divide by the bottom. All right. Since it's a 1, I don't need to do that, but I'm going to take 0.347 times 58.3. I'm going to go back and check my sig figs. You always look at your original measurement. My original measurement has 3 sig figs. So I count my sig figs in this problem. I've got 20.2301. I just start back at the beginning. Here's my first sig fig. Here's my second sig fig. Here's my third. So 20.2 grams. All right. And basically the rest of this page, I'm just showing you this is really all you did here. All you did was take a known number of moles. You did a conversion to get it into an unknown mass. That conversion was simply to do the molar mass divided by 1 mole. So I have to calculate that molar mass out first. The last problem I want to do with you is the opposite of that, which is to take grams and convert it back into moles. So now I have 250 grams of calcium phosphate that I want to switch into moles. So if I were to go to my chart, this time I'm starting with grams. So I have to follow the arrow from grams down to moles. That says to do 1 mole over the molar mass of my substance. So again, I'm going to have to calculate that out. So I'm going to put my calculator back up here. I know it said I'm going to do 1 mole over the molar mass of that. So I just need to add all of that up. Again, if you want to show your work, go ahead, but you don't have to do that anymore for your molar masses. So I've got 3 calcium, so I'm going to do 3 times 40.1. This is 2 phosphoruses, so 2 times 31.0. And that's going to give me 8 oxygens, so plus 8 times 16.0. So my molar mass of calcium phosphate is 310.3. To solve that problem, I take my known times top divided by the bottom. So I'm going to do 250 divided by 310.3. And then I'm going to go back and check my sig figs. 250 has just 2 sig figs. So my answer over here should be 0.8, and I'm going to round that up to 1 moles. So that's really it for the notes today. Not very long, I know. Over here I have the 2 methods that you're actually using. This is the first method that we did. This is now the second. If I started with a certain amount of grams, my conversion is going to be 1 mole over the molar mass, and that'll switch it into my unknown amount of moles. Alrighty. So now that you have that, you can go on to maybe complete the problems from yesterday. Yesterday's sheet was this mole worksheet 1. So on here we were converting between moles and particles. So maybe now that's makes a little more sense for you guys. Your actual blended assignment is definitely this sheet right here. So for each of these, you are going to take them, do a conversion, and get them into the unknown quantity. For these first ones, we want to switch grams into moles. And for these bottom 5, we want to switch moles into grams. Alright, so I've demonstrated both of those ways. You just have to look at what you're trying to cancel out, and that tells you which way you're going to solve the problem. If I go back to the top, I want to cancel out grams, so grams has to go on the bottom. That means moles has to go on the top. And then again, just always go back to the beginning to measurement to check your sig figs. These values in the center here are either constants or they're rounded, and so you can't really tell how many sig figs, so we go back with our original measurement. Okay, so don't forget, your assignment is to complete this, and there is a question in the blended classroom that you have to answer in order to get full credit for this assignment. All right, have a good day, and I will see you on Monday.